Today we're going to be taking a closer look at this wireless cleaning glasses case that I got in the last mailbag. It claims to be a high-frequency ultrasonic glasses cleaner. One-piece wireless multi-purpose cleaning machine for eyewear and accessories. But it does seem to focus on being for cleaning glasses, and it is sized pretty much for exactly that. As you can see, a pair of glasses fits quite neatly in there, and then the top can go back on with no problems. Over here we have a very small control panel. There is a power button which has got a little foam block stuck around it, which I think I'm going to remove. I'm fairly confident that was just to prevent that button from getting pressed in transit. Anyway, there's that button which turns it on and off. Then there's this button which, according to the instructions, meager the instructions are, sets it for either a 10 or a 20-minute timer cycle. I don't know what that 8 does. It might count down. I haven't discovered that yet. On the end of it, we have a USB charging connector. On the bottom, we just have 4 suction cup feet with little Phillips screws inside. That's going to become important later. And other than that, there are no features or markings on the thing. As I mentioned, it comes with this multilingual yet very inadequate set of instructions. And about all it talks about is the power button, the water drop button for... Okay, so that display does do either 1 or 2 to show whether you're in a 10-minute or 20-minute cycle. Other than that, there's not that much information. Just tells you how to put the glasses in so you don't scratch them, and then safety warnings and stuff like that. In the box that it comes in, there's also a small instructions block that tells you to stick it down with the suction cups, cover your item with clean water, and then add an unspecified cleaning agent. Press the switch and it will start going for about 5 minutes. When it's necessary to stop, press the switch again. Not all that useful. So I think before I put my glasses in, I might use one of my old pairs of glasses rather than these cheap sunglasses. But I think first I want to just see how much current it charges at and maybe charge it up a little bit. And then we will throw some glasses in there and try it. And then, of course, we will take it apart because that's the main event of this video. So, switch on. It is drawing 260 milliamps. All right. Not asking for power delivery to happen. It's only at 5 volts. So I think I will let it charge for a little while. I'm not going to charge it right up to full because I don't know how long that's going to take. But we'll give it a few minutes to charge, and then I will come back. Although I do notice it's already dropped down to 210 and 220 milliamps, so this may not take all that long. Okay, it's about 3.5 minutes later, and the charge current has dropped to about 120 milliamps, so it's about half. It's still going to keep charging if I let it, but I think that's enough for now. It's probably fairly close to a full charge anyway. So let's put my old pair of glasses in. Oh, actually, first let's smudge them a little bit and put them in there. And then fill it with water. Just enough to cover the glasses, it said. And then add the cleaning agent. Don't know how much, so I'll just put that much in. According to a web page that I found, it said just use common dishwashing liquid, so that is what I will put in there. Not too much, hopefully. And then put the lid on and start it and push that, and there's the 20-minute cycle, there's the 10-minute cycle. I think I'll let it run for the 10-minute cycle. By the way, does that sound like ultrasonic to you? No, it doesn't, because you wouldn't be able to hear ultrasonic, because by definition, ultrasonic is above human hearing. That is about 125 to 150 hertz. Not kilohertz, hertz. So, obviously, this is not ultrasonic. I'm going to let that go for the next 10 minutes or so, and I will get back to you when it's done. I guess while we're waiting, We can just take a look and see how splashy it gets in there. Oh. Yeah, there are little tiny ripples. Not enough to dislodge or move any of the bubbles around. Just little ripples around the side. Well, we'll wait and see just how much that cleans, I guess. Well, the 10-minute cycle appears not to be that accurate, but I'm getting tired of the noise. Let's see if it did anything at all to clean my glasses. The first thing I note is that there's no obvious crud in there, no oil slick sitting on top of it or anything. I don't think that did any better than me just wiping it with a spray cleaner, quite honestly. Well, I think all that's left after that incredibly disappointing performance is to dump this thing out and dry it off and then take it apart, which is probably what you guys are here for anyway. All right, let's get at these 4 screws on the bottom and just see what we can find inside here. I am thinking that it's going to be a lot simpler than what it suggests. Maybe a microcontroller, probably not even that, I would guess. Maybe just a couple of switches and a few LEDs, and the vibration source sounds suspiciously like a motor with an off-center weight on it. Place your bets down below. So yeah, as suspected, it's a motor with an off-center weight, although I did not expect a dual shaft motor with 2 weights. That's sophisticated, I guess. And down in here we have a circuit board with a little, was it a 14-pin chip on it, a few other components, and a little tiny lithium-ion cell. And a couple of screws holding that in. So we'll just yoink them out and see what happens next. So our cell here is a 3.7 volt lithium-ion cell, 200 milliamp hours. Not a huge amount, but for something like this, probably more than enough. And the circuit board, we have 2 switches, 3 LEDs there, which is, I think, the battery indicator, and then 7 segments of LED here, which is what does the 1 or 2, depending on what mode you set. On this side of the board, we have a little 5-pin chip, which is more than likely going to be battery management or battery charging. A 14-pin IC here, a diode, a single transistor, which is going to be turning the motor on and off, and then just a smattering of resistors and capacitors. That power management chip is an LTH7, which is a familiar sounding name. As expected, the LTH7 is a charge management IC. It is a constant current, constant voltage charger chip, which is exactly what you want for a single cell lithium battery. It can be programmed to charge up to 800 milliamps. This one looked like it was maxing out at about 250, which is reasonable given the size of the battery. You wouldn't want to cook the thing too horribly. And there is the basic circuit of it. The charging LED, the programming resistor to program the maximum charge current. So it looks like the programming resistor on this charging chip is a 272, 27 and 2 zeros, so 2.7K. So the datasheet doesn't really have a chart talking about that programming resistor, but it does show 2 different situations. With a 10K programming resistor, it will be limited to about 100 milliamps. And with a 2K, it would be limited to, depending on the supply voltage, so at 5 volts, it would be limited to just over 500 milliamps. We have a 2.7K resistor in there, so I would guess that would be somewhere between 400 and 500 milliamps total. The 14-pin chip is completely anonymous, as is so annoyingly common these days, but you can see that there are some vias going down there over to the 7 segments of LEDs on this side, and a couple of traces that disappear over to the push buttons, and one trace that comes from the battery management IC. So it's going to be a cheap little microcontroller of some description, no doubt. What else we got left to get a part number off? How about the transistor? It is an A09T. It's just a little N-channel MOSFET, nothing too special going on there. Looks like it can handle just under 6 amps at up to 30 volts, which is more than enough for this application. Just a very basic little MOSFET. And as expected, it is connected to one pin of the motor. And across the motor in inverse parallel is that diode to clamp down on any back EMF. There's also a little capacitor across the motor just to try and smooth out any spikiness and back EMF stuff as well. That's thoughtful and reasonable enough, I guess. So another fairly simple device with most of what's going on inside a microcontroller. It just barely needs the microcontroller. Presumably there is some sort of timing going on inside there, but it's not very accurate. As you saw, my stopwatch was showing about half a minute over the 10 minutes, and I started it probably a minute later than when I started this thing. So who knows if it would have eventually shut off or not. I'm not going to listen to that noise for any longer, though. This thing lies about being ultrasonic. Doesn't do a very good job of agitating things. The only movement that I saw in the water was just right around the edges. It didn't seem to dislodge any of the crud on my glasses any more than just soaking them for 10 minutes would have. Don't recommend it. Still, I'll put a link down below anyway in case you want to go to AliExpress and look at similar items, I suppose. But I wouldn't recommend buying one of these things unless you just want a little bath for your glasses that makes noise. Or if you want to salvage, I guess, a battery and a vibrating motor, you might be able to make something amusing out of that little vibrating motor. Although you'd want to put it on something a lot less rigid than this, because that was really noisy. Anyway, that was a fun exploration nonetheless. Hopefully you got something out of it, even if it is just to learn that you probably don't want to buy this one. Questions and comments down below as usual. I'll talk to you later. And for anyone curious about the beer, this has been a Void Stout from Full Geek Brew Lab in Winnipeg.